Good afternoon, viewers. You are welcome back to Easy Mathematics. Today, we want to continue with the basic 9 lesson. Previously, we talked about the drawing and completing the values of two relations, and today we want to also continue from the same substrand. And previously we were able to look at how to plot the graph for two relations and how to find the graph or the gradient from a graph. Today we are still on the graph, and we want to look at using graph to solve equations involving two linear relations. Now when it comes to the graph, we can use the graph to solve simultaneous equations. And that is basically or mainly what we are discussing for today. But first of all, when we say simultaneous equation, what are simultaneous equations? Now, simultaneous equations are two or more equations with the same variable. Okay, so we can say two or more equations, with the same variables. So once the equation that has been given or have been given have the same variables, then we say these two equations or these equations are simultaneous. So we can solve them simultaneously. As you are solving for the other, you are also solving for the other one at the same time. Now, in solving for simultaneous equation, we have various methods in solving equations simultaneously. So we have the first one, which is substitution. We can solve simultaneous equations in a method known as substitution method. We can also solve in a method known as the elimination method. We can solve simultaneous equation using the elimination method. And finally, we can solve equation using the graph method. And this is what today we want to talk about. How to solve simultaneous equation using the graph. Now, when we are solving equations simultaneously using the graph, we need two things from each of the relations, okay? From each of the relations. So if, let's say, I have an example of equation, let's say y is equal to 2x plus 5 and y is equal to 3x minus 2. With this equation, I need my y-intercept and I need my x-intercept for one relation. So if I want to solve this equation simultaneously using the graph, I need my y-intercept and I need my x-intercept for this relation. Now, because it is a linear relation, on the graph, plotting it on the graph will give me a line. So what I need is basically 2 points. Now, with the y-intercept, it simply means where the line will cut across the y-axis. So the moment the line cuts across the y-axis, it gives me the x to be 0. So what I need is my y-intercept, which gives me a point 0, y, which being the value of y. The same thing with the x-intercept. I also need or want to know where the line will cut across the x-axis. And when the line cuts across the x-axis, giving you the x-intercept, it gives you the point x0. Because the x-axis, where the line cut across the x-axis is 0. So for me to draw this line on my graph, I need these 2 points, being my x-intercept and my y-intercept. So when I want, or if I want my x-intercept or y-intercept, we find the y-intercept when x is 0. And we also find the x-intercept when y is 0. So with these 2 points, I can plot this relation in order to get a line graph. Then also with this relation, I also need the same thing, my y-intercept and my x-intercept. Also the same thing here. The y-intercept for this relation is when x is 0, which is the same thing, but you will get a different point. The same thing that if I want the x-intercept for this relation, the y is 0. So before we can use the graph to solve equations simultaneously, then we need 2 points from each of the equations. So this equation should give me 2 points, or I should get 2 points from this equation. Likewise, I should also get 2 points from this equation. So the moment I get this point, I will point them using my own scale, because I have not been given a scale. So using my own scale, I will plot this point and draw line for this, line for this. Now you will notice that after drawing the line, they will meet at a point. So the point where it's going to meet will give you the value of the x and the y. So this is basically the introduction. That if you are using a graph to solve equations that are simultaneously, one, this is what you need. I should get 2 points from each equation, and this point should be my y-intercept and my x-intercept from each of the equations. Once you have those 2 points, you can plot them on the graph, draw a line, do for the other one. Where they meet becomes the point of intersection, which is the value for x and y for this relation. So we have been given an example that using a graph, solve the relations simultaneously. So the equation that have been given, we have y is equal to minus x plus 7 and y is equal to 2x plus 1. So let's take the first equation. With the first equation, I need 2 points, as explained. I need my x-intercept and my y-intercept. So the first equation given is y is equal to minus x plus 7. So if I want my y-intercept, for short, I can simply say, if I want the y-intercept, then x should be equal to 0. So when x is equal to 0, then we are going to substitute this x is equal to 0 in the equation so that we can solve for the y-intercept to get 1 point. So y is equal to negative x. So we are saying that x is 0 plus 7. So if x is 0 and we are adding this, we get y is equal to 7. So 1 point when x is equal to 0 will give me the point, let's say point A, 0, 7. So this is the y-intercept, which gives you a point. Then with the same relation, minus x plus 7, this time we are going to say when y is equal to 0. Because when y is 0, we will be able to get the x-intercept. And when x is also 0, we will be able to get the x-intercept. When the x is 0, we will be able to get the y-intercept. So now that y is 0, we can solve for the x-intercept. So in place of y, we are going to say 0 is equal to minus x plus 7. So you can choose to take this one here, which will give you 0 minus 7 is minus x. Minus 7 is equal to x, negative x. Dividing both sides by negative 1 will give me the x to be equal to 7. So I can say this should be my point B. 7, the y is 0. Remember we said that if you are using the graph, for each relation we need 2 points. And these 2 points are the x-intercept and the y-intercept. Where you have the y-intercept, x is 0. So this is my y-intercept because x is 0. And this is my y, this is also my x-intercept because y is 0. So now that I have these 2 points, I can draw on the graph and show the line which is y is equal to minus x plus 7. So now that we have these 2 points, let us pause and also find another 2 points for the second relation. Now the second relation has also been given as y is equal to 2x plus 1. So this one, I have to know the x-intercept, also the y-intercept. So taking or looking at this one, if I want my x-intercept or my y-intercept, then x should be 0 and vice versa. So let's say I want the y-intercept. If you want the y-intercept, then we can say when x is equal to 0, then what is the value of y? So in place of x, we are going to write 0 plus 1. So we have y is equal to 0 plus 1. Y is equal to 1. So with this, let's say another point x. Okay, so we want 2 points. So we are naming this point as x. So this being your x, y is 1, x is 0. So this gives you the point 0, 1. Now we have the y-intercept. Now let's find the x-intercept. When you want the x-intercept, then it means y is around 0. The moment y is 0, in this equation, instead of writing y is equal to, we will say 0 is equal to 2x plus 1. So we can bring this one here, give you negative 1 is equal to 2x. Divide by 2, divide by 2. So we have negative 1 over 2 is equal to x, which means x is negative 0.5. So this will give me the point y. Let's say x is negative 0.5 and the y is what? 0. So in every simultaneous equation using the graph, for each of the equation we need 2 points, the x-intercept and the y-intercept. Now that I have the x-intercept and the y-intercept, I can just plot this on a graph. There I can know or determine my x and y axis to know this one. Now that we know 2 points for each relation, we just come to the graph, get our own scale depending on the numbers that we have. Now when you look at the y-intercept, it is 7. And on the y-axis, our highest number is what? Is 6 in 2 centimeters to 1 unit. So that means we have to double it, making it 2 centimeters to 2 units. Then when you come to the x-intercept here too, it's also 7. So we should do the scale as 2 centimeters to 2 units on both axes, on both x and y. And once we are able to do that, we can or we will be able to what? To understand that the scale is going to be 2 centimeters to 2 units. Now, let's go to the graph, plot our x and y axis or the 2 perpendicular lines so that we can quickly get our scale. So this will be my middle line, 1, 2, 3, 4, 5. Let's locate the middle line for y. So we have it there. So this is our y-axis. This is our x. Sorry, this is our y-axis. So we want the middle 1, 2, 3, 4, 5, 6. So this is going to be the y-axis. Sorry, the x-axis rather. Good. So this is our x. Now the point of intersection we know is 0. So now, looking at the numbers that we have, it will be safe for us to use 2 centimeters to 2 units on both axes. So from one thick line to the next thick line, which is the 2 centimeters. From one thick line to the next thick line gives you 2 centimeters. One thick line to the next thick line gives you 2 centimeters. The next thick line, one thick line gives you 2 centimeters. So 2 units. 2, 4, 6, 8, 10. Negative 2, negative 4, negative 6, negative 8, negative 10. 2, 4, 6, 8, 10, 12. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. So now, you see, when you are using the graph, you will not be given a scale. Okay, we should take note of that. But when you are given a scale, fine. But mostly you will not be given a scale, so you will determine the scale that you can use to find or solve the equation simultaneously. So now that I have my scale that will fit what I am coming to plot, now let's do the plotting. Now look at this relation, which is y is equal to negative x plus 7. What are the 2 points that I was able to get? That is the x-intercept and the y-intercept. I was able to get 0, 7. So on the y-axis, locate 7 and indicate your point. So 0, 7 on the y-axis, 7 is between 6 and 8. So this is my 0, 7. Then the second point is 7, 0. That means the y is 0. So on the x-axis, locate 7, which is also between 6 and 8. So this is it. So now with these 2 points, I can draw this relation on a graph. You see, before you can draw a line, you need at least 2 points. So now that I have the y-intercept and the x-intercept, I can draw the relation y is equal to negative x plus 7. So now let's draw the relation which we were able to find both intercepts. Now when you are drawing the line, you should make sure that the line cuts or passes through the intersection of the point. Should pass through it so that we can get the accurate value of what we want. And also know that double lines is advised not to get. So now this line that I've drawn, it is the relation y is equal to negative x plus 7. That is the relation. So now I can now plot these two so that I will also draw the relation. The moment you plot these two and draw the line, you will know that or see that this line and the line we are about to draw will meet at a point. So the point where it's going to meet gives you the value. Good. So now let's look at something here. This is 0, 1. 0, 1. So the x is 0 and the y-axis is 1. So on the y-axis, 1 is between 0 and 2. So this is it. This is the point. Now that we have the point for the y-intercept, you see, what this point simply means that when I draw the line will cut the y-axis at 1. Then also, x is negative 0.5. The intervals here are in 2 units. So 0.5 is not here because between 0 and negative 2 is negative 1. So 0.5 is located between the 0 and the 1. And this is the 1. So this is 0, 0.2, 0.4, 0.6. So my 0.5, negative 0.5 is here. So you see where the point of intersection is for the x. So what do? You just draw a line to cut across the 2 points. So also, we have to just make sure we draw the line that will cut across the point exactly so that we can get our answer correctly. Good. Note that double lines are not accepted. So now this line that we've drawn is the relation y is equal to 2x plus 1. That is it. So now that we have been able to draw this relation which was given in the question, this relation and this relation on a graph, you will notice that the 2 lines meet at a point. So their point of intersection, the point of intersection is the value of y and x, or x and y. which when you should use any of this method, you should get that answer. So now let's locate the point of intersection. The point of intersection is here. They meet here. So we are going to trace it to the y and trace to the x. But we know that points are read from the x-axis first. So we trace the point of intersection to the y-axis and also to the x-axis. Then also to the y-axis. So reading the point of intersection, what do we have? From the x-axis first, we have 2. And from the y-axis, it is here, which is between 4 and 6. That gives you 5. So the point of intersection is 2, 5. And we know clearly that every point is x and y. So this point is x, this point is y. Which means that the value for x in these two relations is the 2. And the value of y in these two relations is the y. So we can say, solving them simultaneously, therefore, x is equal to 2 and y is equal to 5. We have been able to solve this equation simultaneously on the graph. So first of all, what you should know is that when I am solving equations simultaneously, I should locate or get 2 points from the equation. It's very, very important. Once you have 2 points from one relation, you can plot it. 2 points from the other relation, you can plot it. And once you plot them with your own scale, you will notice that they will meet at a point. So the point of their intersection is the value for x and y. Thank you very much. As we said, for you to solve equations simultaneously using a graph, you need 2 points, your y-intercept and your x-intercept. And they are very, very simple to find it. When you need your y-intercept, it means x is 0. And when you need your x-intercept, it means y is also 0. So the point of intersection after drawing will help you to see or know the value. We'll come again, God willing, Friday, and we'll look at the last part, or we'll come with the second example in solving simultaneous equation using the graph. You can drop your comments down, questions or suggestions, or any contribution. Thank you for staying tuned. Bye-bye.